All right, everybody. Here goes a video on graphing square and cube roots. Now, the general form is something similar to what you've seen before. You've seen vertex form before for polynomial equations and all that. Well, it's very similar form, except for you have x minus h in a radical and then a plus k. So your vertex, it's kind of a starting point. Is going to be your h comma k, or it's opposite of what's in the radical, and comma outside. And then you have your a value, which is your vertical stretch or compress. So it's going to stretch it vertically or shrink it vertically. So here are the two parent functions. So we'll talk about those for a minute. So we have y is equal to the square root of x. And we come up with this because it's kind of backwards from a parabola. So you have to think about the square root of 1 is 1. And then the square root of 4 is 2. The square root of 9 is 3. By the time you got all the way out to the square root of 100, you'd only be up to the top 10 for a square root. But also notice it doesn't go back to the left. That's because you can't take the square root of a negative number. Now, cube roots you can, so that's why cube roots go forever in both directions. But this one just runs a lot quicker. So the cube root of 1 is 1, but then your next perfect cube isn't until you get to 8. So the cube root of 8 is only 2. So this one runs much faster. Okay, so now we need to talk about your domain and range. Your domain is x is greater than or equal to the x-coordinate of your starting point. So your starting point is 0, 0. So since it's going to the right, x has to be greater than or equal to 0. And then your range. Your range is your y value. And since it's going up, it's greater than or equal to the y-coordinate of your starting point. Now in terms of cube roots, both of them are going to be all real numbers. Because, as you can see, cube roots go forever in all four directions, up, down, left, and right. So cube roots are easy for domain and range. So what we're going to do is we're going to talk about the different transformations from the parent graph. We're going to graph it, and then we're going to state the domain and range. So let's take a look at the first one. The first one, we have a negative sign. So we're still going to reflect or flip it upside down. We have x plus 2, which means we're going to start at negative 2 comma positive 4, or left 2 and up 4. So that is our transformations. So we're going to start at negative 2, 4, left 2 and up 4. But then we're going to graph down because it's been flipped. And our graph looks like this. So, if we have domain, x has to be greater than or equal to the x-coordinate of our starting point, which is negative 2. But our range is going down. It's going lower than the starting point. So y is less than or equal to 4. Okay? So the next one, last one for today, we have 3 in front. So we're going to vertically stretch by 3. And then we're going to have a 1 to the right and 4 down, which gives us a starting point of positive 1 comma negative 4, opposite of the inside comma outside. So 1 negative 4 puts us here. And then we're going to vertically stretch it. So we would go here, and then we would go down 3 and over 1. Now, how am I getting these points? Well, all you really have to do is type it in your graphing calculator and use the table. Or you can kind of remember that we need to go 8 places to go up 2, but now we're actually going up 6 because of the multiplier of 3. So really, if I were you, I would just type it in your graphing calculator. But you should get a graph that looks like this. So it's just been vertically stretched. But remember, your domain and range for cube roots are going to be all real numbers. All right, that's it for this video. Pretty short and sweet, but remember, you don't have to graph these by hand. You can just use your graphing calculator. This is Longo, and I'm out. See you, bye.